In my previous videos, I've done an overview of how to set up Gluster bare metal on Fedora, and then how to use Heketi as a REST API on top of a Gluster cluster to dynamically provision storage from that cluster using an API. So now that we have an API and a storage cluster, we can integrate that into Kubernetes and OpenShift. I'm going to do it in Kubernetes here to create a dynamic persistent volume provisioner for pods. So that's what I'm going to demonstrate here today. So let me open up this file. So here is how you create the storage class resource for the Gluster provisioner. So storage class is a special kind of resource that lets Kubernetes know how to, it's a plugin for dynamic provisioning of persistent volumes in Kubernetes. And for each plugin, there's different resources that are needed. In this case, you need the REST URL, the API endpoint there. And then in my previous video, I set up the Heketi API to not use authentication, and this authentication is needed, so I set that up, but it's pretty easy if you go into the JSON configuration file for Heketi. The comments show you how to do it. So the user is this. We're using the default namespace in Kubernetes, and that's where this secret is going to be, and the secret is defined right up here. This is the base64 encoded password that's super secret. It's admin secret. So so we're going to go ahead and create that. And that doesn't really create any objects in our namespace. It just educates Kubernetes on how we want our storage to be dynamically provisioned. So if we do a get all here, we just set the Kubernetes service. So next I'm going to create a demo pod. I'll show you this real quick. So here's the persistent volume claim. Note that I haven't created a persistent volume for this claim to bind to. It's going to be dynamically created because I have this annotation here saying storage class default. And the storage class object that we created earlier, its name is default. That's how it knows which plugin to use. And then I say, give me 8 gigabytes of storage. And then the name of this persistent volume claim is Gluster volume. And then here I've just got a replica set. I'm setting it up as a replica set because I'm going to prove that the storage is persistent later by killing the pod and having the replica set regenerate it. But we're going to create a mount. So if we go down here, the cluster volume, we're going to name it my vol as a volume in the pod spec, and then mount that at /mount. And then the main entry point for the container is just going to sleep. That way we can exec into it and do a test. So let's create that. So when we do that, in the background, Kubernetes is going to run off and use the Gluster dynamic provisioner to create a Gluster volume and then bind that to the persistent volume claim. So if we look at the persistent volume claims here, we can see that our Gluster volume is bound to this persistent volume, and this was dynamically created for us. If we go in and describe the PV, we can see here that the type is GlusterFS, and this endpoint's name here is interesting. Well, I'll show that here in a second. But this is the volume that Heketi created for us, right? And this kind of looks like a Heketi volume name here. And that is the Gluster volume backing this persistent volume in Kubernetes. So if we go in and we describe the Gluster dynamic Gluster volume service, you can see here that it has a set of endpoints here. And these are the port numbers are irrelevant, but the IP addresses are the IP addresses of the Gluster nodes. And if I switch over here to Heketi and we do a cluster info, cluster info, topology info, you can see here that those endpoints in that service in Kubernetes are all listed, all nodes in the Gluster cluster. So let me jump back here. So now that we have that running, let's go into the pod. And we're going to write something into this persistent volume so that we can prove that it's persistent. So if we come in here, we can say echo testing into mount A. We can go echo mount, not echo, cat mount A. All right. So let's exit out of this. And then we're going to delete this pod. And because it's part of a replica set, the replica set will recreate it. But the pod does go down, and the storage, is going to be rescheduled, potentially on a different node, and have to have the persistent storage mounted on that node. So we can delete that. But by the time we can type in the new command, we can see that there's already a new pod running, and it's been running for 5 seconds. So if we exec into that pod, we should still see our file A with testing in it. Let's make sure that that's right. And we do. So we get what we expect there. So let's exit out of here. And if we delete our demo, so that's going to delete the deletion of the pod doesn't really matter, but the deletion of the persistent volume claim matters, because when the claim disappears, the dynamically provisioned persistent volume underneath it will be deleted automatically. So we're going to go ahead and do that. And if we do a cube control get all, you can see it's all gone. And so the persistent volume claim and the persistent volume underneath is gone. And if we jump over to our Heketi CLI machine and list the volume's gone. So you can see the dynamic provisioner provisions storage and then cleans it up afterwards. So this is really cool, and yes, hopefully this was useful to you.